Today is day one of your STAAR review. We've already talked about functions, and we're going to continue talking about scientific notation today. So we're going to be looking at this foldable here, and it is going to be glued at the bottom of page 1. You should have already set this up, so for most of you, it's already glued in. For those of you that haven't, if you skipped the video, it's right here. So we're going to go ahead and start off by first looking at standard to scientific notation. So looking at the left side of my foldable here, we are going from standard to scientific notation. So this means that I start off with my number expanded, and I'm trying to get it into scientific notation or scientific form. So if I start off here, right now my decimal's at the very end. I want my decimal to go after the first non-zero number, so that means it needs to be placed after the 2. So I want to find the distance between these two decimal points. So starting from here, I'm going 1, 2, 3, 4, 5, 6, 7 to the left. So I moved my decimal point 7 to the left. Since my number was a very large number, I start off by doing 2.64 times 10 to the 7th. And it's a positive 7, again, because this was a very large number. But looking at the other side here, this number is less than 1. It's a very small number. So here's my decimal point right now. Again, I want to move it after the first non-zero number, so that means my decimal point wants to be moved here. So starting from my original decimal point, I'm physically moving this to my new spot, to my new decimal place, and I'm going 1, 2, 3, 4, 5 to the right. Now, since I started off with a very small number, I'm going to go 2 times 10, and since I moved it 5 times, and since it's very small, this is going to be a negative 5. And then we also have scientific to standard notation. So scientific to standard notation, you start off with your answer in scientific form, and we want to get it into standard form. So what these numbers mean, I'm going to look at my exponents to see how I'm going to manipulate my number to get to its expanded form or its standard form. So since my exponent is a negative number, this is telling me to move it left. So here I'm going to take my decimal point and I'm going to move it to the left 1, 2, 3, 4 times. Here's my new decimal place, and these get taken in by zeros. So here my number now becomes 0.000135. And then we also have my other number. I know this is going to be a very big number because my exponent is positive. It's since my exponent is a positive 6, this is telling me to go to the right 6. So taking 5.8, I'm going to move my decimal point 6 times to the right. So this is 1, 2, 3, 4, 5, 6. Okay, so let's go ahead and look at a couple of examples. So from your foldable, we're going to go ahead and open up this first flap, and we're going to be looking at number 1. So for number 1, it says the approximate average distance of Neptune from the sun is 4,500,000,000 kilometers. How is the distance expressed in scientific notation? So before we do that, I want you to go ahead and look down here at the scientific notation format. Now, again, the number in front of your decimal point has to be a number from 1 through 9. So this cannot be a double digit, and it cannot be 0. And then you would put the rest of the numbers, you would multiply it by 10 to the power of. So if your exponent is big, so it's greater than 10, so it's positive, this is positive. This means you're going to move to the right. If your exponent is small, which means it's less than 1, it's a negative number, you're going to move to the left. So here I have a very big number. I have, again, 4,500,000,000. My decimal point is right here. I want to get this after my first non-zero number, so it's going to be placed right after the 4. So I want to physically move this to my new decimal place, so this is going 1, 2, 3, 4, 5, 6, 7, 8, 9. So I move this 9 times. So I start off with 4.5 times 10. And since I moved it 9 times and I started off with a very large number, my exponent is going to be 9, which means my answer here is C. But if I start off in scientific form like number 2, it says at its perihelion, the Earth is 1.47 times 10 to the 8th kilometers from the Sun, which represents the distance in standard decimal notation. So here I have 1.47 times 10 to the 8th. Since my exponent here is a positive 8, this is telling me to move my decimal place 8 to the right. So starting off with 4.7, I'm physically going to move this 8 times to the right. So this goes 1, 2, 3, 4, 5, 6, 7, 8. And here's where my new decimal place goes. And in the place of all these loops, you're going to get placeholders of 0. So my number is now, let's go ahead and place our commas, or let's rewrite our number. So this is 147,000,000,000. So this is 147 million. So the one that matches this is going to be 147 million kilometers, F. Okay, so lastly, going back to your foldable, this is what you should have written down. If you need a second to pause it, go ahead and do so. Otherwise, you're good to go and work on your assignment for your first day of STAAR review.